Hey guys, this is Miss Vasinka. We are doing area of trapezoids, rhombuses, and kites today. You guys will be able to find the area of these three different shapes. So the formula for the area of a trapezoid, a trapezoid has two parallel sides called bases. Now make sure that you write this on your notes. So base 1 and base 2. Notice how both those bases are different lengths. The height is the perpendicular distance between the bases, so again it has to make a 90-degree angle. Two trapezoids, if we put them together, they actually form a parallelogram. So we're going to take that first trapezoid and basically we're flipping it over. So we have, base 1 on the bottom now and base 2 on the top. Keeping that in mind, so we have our parallelogram. We want to recall the formula for the area of a parallelogram, which is base times height. Now, if you're looking at this, we have this whole piece is our base. So we need to do base 1 plus base 2 instead of just a base. So that would be base 1 plus base 2 times height. Now, you guys know that a trapezoid is half of a parallelogram, so the equation for this would be 1/2 times height times base 1 plus base 2. The most important part is that you have this plus sign here. You need to make sure that you do a plus sign. Some of you, the biggest mistake would be you're writing 1/2 times height times base 1 times base 2, but that is not correct. You want to make sure that there is the plus sign in between. Okay, so a car window is roughly shaped like a trapezoid, so we are going to find the approximate area of this window. So the height is perpendicular to both bases, so if it's perpendicular down here, it has to be perpendicular here. So this would be the height, and these are the bases. These values over here, we are not going to use because first, they are not perpendicular to the bases, they are not parallel with the bases. So those values are only needed when we do perimeter. Okay, so we are going to plug in 18 for the height. Base 1 is 20, base 2 is 36. It doesn't matter what order you put those in, just as long as you keep them in parentheses so that they add together before multiplying times 18. So your answer here, again, if you want to add these two up to make 56 first before you put it all in your calculator, that's fine. So you should get 504 inches squared. The approximate area of Nevada, so the height is always between the two bases. So even though it doesn't say on here that it's perpendicular, we can definitely assume because it's asking, we're learning about trapezoids here right now. So the height would be 309, the base 1 would be 205, base 2 would be 511. You're going to add 205 and 511 together first, and then multiply that all together in your calculator, and you get 110,622 miles squared. Now for example 3, this one is a little different because we do not have the height, so we need to find the height. We can draw in a line that creates a right triangle and a rectangle here. So if you think back to last chapter, last quarter, we did the Pythagorean theorem. So we can use the Pythagorean theorem to find h. We know that this whole thing of DC is 16. So if this piece is 11 up here, this piece would also have to be 11. So the other little piece would be 5 feet. So now we just need to do the Pythagorean theorem. We have h squared plus 5 squared equals 13 squared. We get 25 and 169, and then we need to subtract 25 from both sides, and we get h squared equals 144. And then take the square root of both sides, you get h equals 12. So my height is 12, and now I have my two bases. So I can go ahead and do the area for a trapezoid. and do 1/2 times 12 times 11 plus 16. And again, if you want to add up that 11 plus 16 first so that you have room for less mistakes, that would be fine. But your answer should be 162 feet squared. Example 4, you guys try it, pause the video to go ahead and try it, but it's the same style as number 3. So we do need to use Pythagorean theorem. This is already split up for us, so if this top side is 5 up here, this would also be 5. We do not know what this is here, so we need to find that out. We're going to use Pythagorean theorem to find that. So we have x squared plus 8 squared equals 10 squared. 8 squared is 64, 10 squared is 100. We subtract the 64 from both sides, and we get 36. Then we take the square root of both sides, and we get x equals 6. So we know that this is 6 here, and then we have to find the bottom base. We can't just use one of those. So 6 plus 5 is 11, so the whole bottom base is 11 meters. Now you have your height, you have your two bases. So we have 1/2 times 8 times 11 plus 5. Put that all in your calculator. You get 64 meters squared. Formula for the area of a kite or a rhombus. So they have the same exact area, okay, but there are a couple different things about kites and rhombuses that are different. So we are going to draw the diagonals of a kite first of all, or rhombus, doesn't matter. The diagonals are perpendicular, okay? Half of a triangle, or a triangle makes up half of a rhombus, rather. So the area of a triangle is 1/2 base times height. Now the base is the same thing as one of our diagonals, so we're going to plug that in for base. So we would have 1/2 times diagonal times height. Now that only represents 1/2 of our rhombus, okay? So going back to this, where we have the height and the diagonal, two triangles form a rhombus. So that means that this base of the triangle is a diagonal, and then this height plus this height here makes another diagonal. So what we're going to do is, instead of doing this long formula here where we do 2 times 1/2 diagonal times height, we can make it easier because these two values there make up diagonal number 2. So we can get rid of those, and then we can have the area of a rhombus or a kite is 1/2 times diagonal 1 times diagonal 2. Make sure that you don't add those two. They need to be multiplied. A kite is the same exact formula, 1/2 times diagonal 1 times diagonal 2. Now, for kites, okay, kites have two pairs of adjacent congruent sides. So this side is congruent to this side is congruent to this side. Their diagonals are perpendicular, but they are not congruent. So, you know, XZ is a different length than YW. And one diagonal is bisected. Bisected means split in half in two equal pieces. So if you notice, XZ here is bisected because we have 3 and 3. The other side is 1 and 4, or the other diagonal is 1 and 4. Okay, so now let's find the area of this kite. We need to find the lengths of the diagonals first. So all you need to do is add them up. Diagonal 1, it doesn't matter which one you start with, but diagonal 1 is 6. Diagonal 2, 1 plus 4 would be 5. And then we need to use the formula for the area of a kite. So we're just going to plug it in. 1/2 times 6 times 5, which would be 15 centimeters squared. Again, you're doing area, so you need to do the correct units there. You guys can try this one if you want to pause it or just follow along. So my one diagonal is already written on there for you. It's 7 feet. The other one has 4 feet and 4 feet. So I need to add those two together to make 8 feet. We are going to just plug it into our formula. We have 1/2 times 7 times 8, which would be 28 feet squared. Okay, most important thing about a rhombus is that, again, the diagonals are perpendicular, but they're not congruent. So you might have one that's like 24 and one that's 10, but both diagonals are bisected. So this 12 feet is congruent to this 12 feet, and this value is congruent to this value. That is the difference between the rhombus and kites. Okay, so I'm going to apologize. My dogs might bark, so sorry in advance. So the first diagonal is 24 because we're adding the 12 feet but plus 12 feet. We do not know what the other diagonal is, so we need to go ahead and use the Pythagorean theorem to find that missing half of the diagonal. We know that these are perpendicular. So there's a 90-degree angle, so we can use the Pythagorean theorem. We can do y squared plus 12 squared equals 13 squared. 12 squared is 144, 13 squared is 169. You would subtract 144 from both sides, and you would get y squared equals 25. Then you need to take the square root of both sides, and you get y equals 5. So if this y equals 5, both of those pieces equal 5 because they are congruent to each other. And then that means diagonal 2 is 10 feet. So then we'll use the formula. We plug them in, 1/2 times 24 times 10, and we get 120 feet squared because we are talking about area. So example number 4, you guys can try this, pause your video. The most important thing here is that you have a diagonal already. We do not have the other diagonal, so we need to draw that in from corner to corner. That diagonal splits the other diagonal, the 6, into 2 equal pieces, 3 and 3. And then we are going to have to find the missing piece. So one of these y's we need to find. So if this is 5 centimeters, all of these are 5 centimeters, so we could basically do the Pythagorean theorem on any one of those triangles there. Okay, so y squared plus 3 squared equals 5 squared. 3 squared is 9, 5 squared is 25. We're going to subtract 9 from both sides. We get y squared equals 16, and then we get y equals 4 when we take the square root of both sides. So both of the y's are 4, which means my diagonal 2 is 8. Okay, so plug it into the area formula. 1/2 times 6 times 8, which equals 24. So the area of this rhombus is 24 centimeters squared. Okay, now the next couple of problems here, I'm just going to do them really fast. This is just a practice for you guys. You should definitely pause the video and try them before you just write them down, because this is a review for you. So area here, this is a triangle. It's 1/2 base times height. The base here is 4. The height is 3.4. We are not using the hypotenuse. So my answer here is 6.8 feet squared. Put that all in your calculator. All the answers are going to be like this, so look out for that. I'll do the start of it, but I'm not going to write this piece like I just did. This is a parallelogram. These two sides are congruent and these two sides are congruent, but this here is the height, so I need to do parallelogram is base times height. If you don't have your cheat sheet, get your cheat sheet out. When I multiply those two together, I get 3.9 inches squared. The next one is a trapezoid. Okay, remember the two bases and the height are the only thing that we are going to use. We are not using the side lengths of those two sides. So, whoops, we are going to do 1/2 times 3.2 times 6 plus 3. And again, you can take it a step further and do 3.2 times 9. And then put all that in your calculator and get your answer of 14.4 centimeters squared. This is a rhombus. You know it's a rhombus because this side is congruent to this. This is congruent to this. That is not a kite. That is not a trait of a kite. So we have area equals, we need to figure out diagonal 1. I'm going to do these, which would be 6. Diagonal 2 is my tens, which would be 20. So I'm going to do 1/2 times 6 times 20, and I get 60 centimeters squared. Again, make sure you're putting the units down. If you don't put the units down, it's going to be wrong on your test. This is a trapezoid. We do not need to use this value here. We're using the height and the two bases that are perpendicular with the height. So we have 1/2 times 5.5 times 6.5 plus 2.3. Again, if you want to combine those terms first, you can before you put it into your calculator. There is less room for error then. This is 8.8. And then you get your answer of 24.2 yards squared. Number 10, okay, a lot of you guys had a hard time with this one. The height, again, is always perpendicular with the base. So the only two values that you are using is this. You're not using this or this. The area is 1/2 base times height. Plug it into your calculator and you get 22.4 feet squared. Number 11 is a kite. You know it's a kite because it has two pieces that are congruent. The other two pieces are not congruent. We need to figure out the diagonals first. Diagonal 1, I did these two, which is 18.4. Diagonal 2, I did the other two, which was 20.7. You're going to plug it in. A equals 1/2 diagonal 1 times diagonal 2. And you get 190.44 meters squared. Number 12, this is a triangle. We had to extend the base out a little bit to get our height, because if we just did it right here, it would not account for the rest of the triangle over here. Sorry, one of my dogs is going to bark right now. We need the base and the height. We are not using this. So we have 1/2 base of 6 times height, which is 4.7. Multiply that all together, you get 14.1 meters squared. Number 13 is a trapezoid. You are not using the side that is not perpendicular or parallel with the bases. So we have 1/2 times the height, which is 7.3, times the two bases added together. Add these two together first so you have less errors. 3.3 plus 7.9 would be 11.2. Multiply them down and you get 40.88 kilometers squared. The most important thing here, guys, is that you actually know your shapes. You cannot use the same formula for every single shape. It will be wrong. You will not get the correct answer. You need to actually look at the shape and figure out what formula you need to use first. These are for the cheat sheet. You can write this stuff down on yours if you want, or you should write it down. You can use a cheat sheet on the test, so please make sure to write that down on this page and this page. If you need to pause it, go ahead and pause it.